So in this video I thought I'd work through a few more problems when it comes to factorizing algebraic expressions. In particular, I'm going to focus on a very brief introduction into factorizing quadratic expressions. I'm going to save a much more in-depth discussion on factorizing quadratics for the quadratics playlist. Usually when one actually is first introduced to factorizing quadratics, you're also introduced to a number of formulae such as difference of two squares, completing the square, etc. I'm going to save all of that for the quadratics series. This video is just a natural extension of our previous discussion on factorizing algebraic expressions. So for instance, we're given 6x squared plus 9x. Whoops, and that should be a squared, 6x squared. I'll write that a little bit more neat. 6x squared plus 9x. So in a recent video we covered, okay, that firstly we have to look for their greatest common factor. In this case it's 3 because 3 goes into 6 into 9. We can also factor out an x here, so we can factor out 3x, right, which is going to leave us with 2x plus 3, because 3x times 2x, if we were to expand this back again, 3x times 2x is 6x squared, 3x times 3 is going to give us 9x, right? Because expanding is, I'll just actually do it this way, expanding is the opposite of factoring. But now in this example, in this question, we're given a quadratic, basic quadratic, x squared minus 5x minus 6. Okay, if you're not used to quadratics, the standard form of a quadratic expression is ax squared plus bx plus c, where a cannot equal 0. Okay, there are different ways. I've seen people approach the factoring of quadratics in different ways. Personally, I mean, the more formal approach, I suppose, would be that you work firstly, the first step would be to work out AC. So if a is 1, right, because 1 is implicit, there's a 1 in front of this x, you don't need to write it, it's implicit, but I will for the sake of this video. And then b is minus 5, right, because b is minus 5 here, and then c is minus 6, right, because you can see here, c is minus 6. And I can denote these in different colors to make it stand out if you like. That's a. Use blue for b, right, blue for b, and orange for c. Okay, now go back to white. So the first step in factorizing a quadratic, you'll be told is to work out AC. Okay, so if you have something greater other than 1, it'd be greater than 1 because a cannot equal 0. Say for instance 2x squared here, then you would multiply a and c. So you'd multiply 2 times negative 6, which would give you negative 12. Okay, and then you'd want to factor out, and then the second step would be to work out 2 factors of AC, which would be negative 12. Work out 2 factors which then add to give you b. Okay, and then from there you can rewrite the bx term using those 2 factors. But to make it a little bit more simple, if I just rub all of this out, we don't need this here. Okay, because it's actually quite a simple process. If you think this is a 1x, right? Okay, so what multiplies to negative 6 and adds to negative 5? That's what we have to find out here. So negative 6, what multiplies to negative 6? Well, 1 and 6 multiplies to 6. 1 times negative 6 would still give us negative 6, and 1 plus negative 6 would give us negative 5. So that's what we're looking for. Okay, so now we rewrite this b term, okay, with the 2 factors that we've just identified of AC. Okay, so in this case, we can rewrite this as x squared, right? There's a 1, I'm not going to write it. X squared plus x, right? I mean, that's the same as writing just plus 1 plus x, or write 1 plus 1x just so you can follow along, minus 6x minus 6. Okay, so this is, here we've rewritten the bx term using these 2 factors. And then next we want to factorize the first 2 and the last 2 terms of this expression. So we want to factorize again. Now, when one becomes much more proficient in factorizing quadratics, you'll be able to rewrite this second line in your head quite quickly, and you'll know, okay, I'm going to rearrange this because I can factor out a 6 if I couple these two, and I can factor out an x if I couple these two, right? And that's exactly what we're going to do. Because the common factor in this first, if we call this a separate expression for the sake of it, in these first two terms, would be an x, right? We can factor out an x, and that's going to leave us with x plus 1. In this case, we can factor out a negative 6, right? Negative 6, and that's going to leave us with an x plus 1. And this is where we want to be. You'll know generally that you're on the right track in your factorizing of a quadratic when you end up, usually in your third line, with something like this, where you factored out and you're left with, in brackets, the two identical couples of terms right here, okay, like x plus 1, x plus 1. Because now we can factor out this, like so, and that will leave us with x minus 6. So all of this simplifies to x plus 1, right, and then x minus 6. And we've successfully factored this quadratic. To do another example, I'm just going to rub this out to save a bit of space. It's storming outside right now, so I apologize if you hear loud booming thunder. But let's do another one. Let's do one that's a little bit more complicated. Let's say we have, I'll write it here, 3. So let's say we're given, in this case we're given 6x squared minus 11x minus 10. And building on what we talked about in this problem, first thing you're going to want to do now is solve for AC, right? This is A, B, C. Well, 6 times negative 10 is minus 60. So we want to figure out what multiplies into minus 60 and then also adds to negative 11. In this case, well, I guess let's just first work through. We need to figure out what's going to multiply to negative 60. Well, 1 and 60, right? But that's not going to get us anywhere close to 11. You can say 6 and 10. That's still not going to get us anywhere close to negative 11. We could look at 4 and 15, actually. We'll probably do it. 4 and 15, right? That's going to equal negative 60. But it also has to add to minus 11. So if this is a negative 15, then 4 times 15 is 4 times negative 15. 4 times negative 15 will equal negative 60. 4 plus negative 15 will also equal negative 11. So these are our two terms, 4 and negative 15. So we can rewrite this then as 6x squared plus 4x minus 15x minus 10. Okay, oops. And now we can factor out this a little bit further. So in this case, these two, we can factor out a 2 and an x. It's going to be 2x, which is going to leave us with 3x plus 2. And in this case, we can factor out a 5, and it could be a negative 5, which will leave us with 3x plus 2. Okay, now we can factor out a 3x plus 2. So what we're left with is just a 3x plus 2 and a 2x minus 5. And we're done with that problem. Do another one. Let's look at question 4. We are given following quadratic: x squared plus 5x plus 6. Okay, so again, this is just a 1, so we just have to work at AC. Well, 1 times 6 is 6. So what multiplies to 6? and adds to 5. Well, 1 and 6 definitely works, but that's not going to add to 5, right? That's going to add to 7. 2 and 3 adds to 6, or multiplies to 6, and then adds to 5. So we've got our two terms. So now we can write this out as x squared plus 2x plus 3x plus 6, and here we can factor out an x. Yep, it's the only thing, that's all we can factor out. So x, and that's going to be plus 2, and then here we can factor out 3, so it's going to be plus 3. That's going to leave us with x plus 2. Okay, now we can factor out an x plus 2. Right, we just factor one of these x plus 2's out, and now we're left with x plus 2, x plus 3. Okay, and we're done.